Drones navigate and avoid obstacles using a combination of sensors, software algorithms, and real-time data processing. Most modern drones are equipped with technologies such as GPS for global positioning, inertial measurement units, IMUs, to track orientation and movement, and various obstacle detection sensors like ultrasonic sensors, infrared sensors, LiDAR, and visual cameras. As a drone flies, its sensors continuously scan the environment. For example, stereo cameras or LiDAR can create a 3D map of the surroundings, allowing the drone's onboard computer to identify potential obstacles, such as trees, buildings, or power lines. Ultrasonic and infrared sensors are often used for close-range detection, especially during takeoff, landing, or indoor flight. The drone's flight control system processes this sensor data in real time, using algorithms to calculate safe flight paths and make split-second decisions. If an obstacle is detected, the system can automatically slow down, stop, or reroute the drone to avoid collisions. Advanced drones may also use machine learning to improve their navigation and obstacle avoidance over time, adapting to new environments and unexpected challenges. In summary, drone navigation and obstacle avoidance rely on a blend of precise sensors, sophisticated software, and continuous data analysis to ensure safe and efficient flight.